Hey everyone, so in this video we're going to continue with our Python fundamentals by learning how to use conditional logic in modular arithmetic. So remember from last video that we have a data type called booleans, and these are used to represent the truth values of logic, which are of course simply true and false. So we can use these Booleans as elements in conditional statements and expressions. So generally speaking, a conditional statement is just an if-then expression. And in English, we hear these all the time. So we could say, like, if it's raining outside, then you should close the windows. And that would be an example of conditional statement. In Python, we create these using elements such if, elif, and else. This allows us to create programs that will execute code based on whether a given Boolean value evaluates to true or not in these statements. So let's see how that would work. So let's say I want to make a very simple function that behaves according to the rules of blackjack. It takes one input, which is equal to the value of my current hand, and then the second input is the value of the next card I'm going to receive after saying hit me. So let's define this. So we'll call it blackjack. And like I said, the first input will be my hand, which is an integer value of my current hand. And then the next input will be an integer value of the next card that I'm going to be given after saying hit me. So since we want this to behave according to the rules of blackjack, it's going to return one of three options. We'll return game over if adding the new card to my next hand or to my hand puts me over 21. It will return winner if my new hand is equal to 21. And otherwise, we'll just return the updated value of my hand plus the next card, which is the new value of my hand. And we can create this functionality using conditional statements. So let's try that. So like I said, the first case is the case where it's game over, which is when my hand plus next card is greater than 21. And so like we say if my hand plus next card is greater than 21, which is part of the reason Python is nice, because that's very readable, it's clear what it's saying, and then we can return a string of game over. And then so our second condition is when my hand plus next card is equal to 21, which is when we win. And so we can say another condition by using elif, the builder I mentioned over here. And this is pretty much means that if this is not true, then check otherwise if this statement is true, which is my hand plus next card is equal to 21. So this statement will be the next thing checked after this returns false. And in this case, we want it to return winner, because in blackjack, if you hit 21, you've won. And then lastly, we want it to return, if neither of these are true, we want it to return the value of my new hand given my current hand and the next card. And there are two ways you can do this. One way is just to say else, and this else will get hit when all the statements before it are false. So it's pretty, it literally just means like otherwise or else return new hand, and then we have to concatenate it with a string, which we can cast my hand plus next card. So what this does is inside the parentheses, we're adding the two integer values together to get the new value of my hand, and then we're casting it into a string so we can concatenate it with new hand. And this is one way to do that, but it's sort of better form that this else statement is really unnecessary since this is the end of the function. So we can actually get rid of it because the function goes line by line. When if returns false and this elif returns false, it will just simply return this, which is equivalent to just saying else. And this is a little cleaner. So now we have that. Why don't we test it with some values for hand in my card and next card. So I'm just going to copy and paste a few test cases that I wrote. And so you don't have to watch me write all those out. So these are just a couple of hands. So like let's say I have a hand of equal to 14, then I'm going to receive a 3 after being hit, and then similarly 18 and 4, and so on. So let's see what these all do. So here we can go one by one and see if they're correct. So we want 14 plus 3 is less than 21, which means in blackjack, I'm still good after being hit. So we want it to return new hand. 18 plus 4 is greater than 21, so that means I've lost, and as such, I receive game over. And with 10 plus 11, 20 plus 1, those are both equal to 21, which means I've won, and it returns winner. And then 4 and 7 together is, again, less than 21, so it's a new hand. And then 10 and 12 is greater than 21, so it's game over. So this behaves exactly as we want it to. Great. So that's just really a very simple way of using conditional statements in Python. Again, you have an if statement, you have an elif statement, which is hit if the if statement is false, and then you can do an else, or if it's the end of the function, you can just return. But again, just in general, you can have as many of these elifs as you want. So you can just have whatever you want here, just call a statement and then return something, or do whatever, and then you can have another. You can just keep going with elifs as many as you want. That doesn't matter. All right, great. So now that we've covered a little bit of conditional statements and expressions, I want to go on our next topic of modular arithmetic. So modular arithmetic is really just a system of arithmetic for integers where numbers wrap around upon reaching a certain value. A good way to think of this is really just like a clock. In a clock, every time the hour would go above 12, it wraps back around to 1. And this sort of arithmetic is used to calculate remainders when dividing one integer and another. And we call this sort of operation the Modulo Operation. And an example of this would be, so if I say 14 modulo 12, then we get 2, because 12 goes into 14 once, and there's a remainder 2. And similarly, if I say 12 modulo 12, or 26 modulo 12, then we still get 2, because now 12 goes into 26 2 times, but it still has a remainder of 2. So 14 modulo 12 and 26 modulo 12 are the same thing. Or if I were to do 24 modulo 12, then we get 0, because there's no remainder. 12 goes into 24 exactly 2 times. So we do this using a modulo operator. In Python, and most, I believe every programming language, the modulo operator is written using the % sign. And so in Python, let's take a look at this now. If I were to print 14 modulo 12, then I get 2, as I said. And for now, let's just comment these out, because we don't want to see all these print statements. And again, if I want to print 26 modulo 12, I once again expect to get 2, or again 24 modulo 12, I want to get 0. So let's see what we get here. Exactly. So we get 2, 2, and 0. So it's exactly as I'm saying. So this is essentially meaning that whatever number you have to the left of the modulo operator will wrap around this number as many times as it can until it can't anymore. So like if I were to do print 3 modulo 12, 3 doesn't go into 12 fully any times, and it just has its value is its remainder. So when I print that, we get 3, as we would expect. So let's see how we can use this in conjunction with conditional statements to do a few interesting things. So one of the common use cases of the modulo operator is to determine whether a given number or integer is odd or even. So let's write a function called isEven, and we're going to pass that function num, which will be an integer. And then, how do we know if a number or an integer is even? Well, it essentially means that if we do that number modulo 2, we expect 0, because any number divided by 2 that is even will have a remainder of 0. 4 divided by 2, 6 divided by 2, 8 divided by 2, so on. We know that if we do that number modulo 2, it will be 0 if it is even. So if num modulo 2 equals 0, and again, as we saw before, you test equality in Python using a double equal sign. Just, it's these basic comparators. And here is greater than, you can do less than, you can do less than or equal to, greater than or equal to, so on. And the only really kind of unusual thing is that equal to is a double equals, but this is because a single equals is how you assign a variable, so they need to be distinguished. So if num modulo 2 is equal to 0, we want to return true, because it is true that this number that we're passing the function is even. Otherwise, we want to return false, because if it's not equal to 0, we know the number is odd. So we can very easily test this on a variety of numbers. So we'll try 1, we can try 2, 2, and we can even pass it some negative numbers because it's still just treating it as an integer, so the negative does not matter. And so let's see what all of these do. And again, I'll comment these out so we don't get confused what's going where. And now if I hit run, cool. So yeah, 1 is not even, so the function returns false. 2 is of course even, returns true. 5 is not even, returns false. Then 10, -10, -2 are all even integers, return true. So it behaves exactly as we want. And so with just a little function like this, we can test whether or not a number is even. And it's very common to do this in a variety of programs, and it's just really nice to have a little easy function like this that you can call, because then if I have a greater function, I could, inside the function somewhere, say in a statement, if is even whatever the number is, then I want to do whatever over here in this body. And that's again how you can build modular arithmetic and conditional statements very easily together. All right, so I think that's all we're going to cover for today. So we just learned a little basic overview of conditional statements and some modular arithmetic and see how those work together. So in our next video, we're going to learn about 2 new data structures in Python, which are lists and tuples. And these are very useful and used all the time in Python programming. And it'll be cool to learn about those. So anyways, thanks for watching, and I'll see you next time.